How does the change in the SEI film components with depth contribute to the understanding of the surface properties and behavior of the electrode material during its use? What other factors could be considered when interpreting the XPS data for material composition, structure, and oxidation states in the context of energy storage applications? How does the ability to measure material composition at various depths improve the overall understanding of the material's properties and performance in practical applications? Can Davis Syrinz manufacture solid-state sodium-ion batteries made from seawater in Latvia? What can be inferred from the XPS full spectrum of Co 0.85 Se at RGO? And how does it help in understanding the material's composition? How does the schematic diagram of components at different depths aid in visualizing the distribution of elements or phases within the material? What does the XPS skin spectrum of different depths reveal about the variation in elemental composition, and how does this depth-dependent analysis provide insights into the material's surface and internal structure? How can comparing the full spectrum, the schematic diagram, and the XPS skin spectrum help in comprehensively understanding the material's characteristics? What are the advantages of examining the material at various depths using XPS, and how does this approach contribute to a more detailed analysis of the material's properties? What role does depth profiling play in identifying changes in elemental composition, oxidation states, or chemical environments within the Co 0.85 Se at RGO composite? How does the XPS technique allow for a detailed study of the material's surface and the composition changes beneath it, particularly for layered or composite materials like Co 0.85 Se at RGO? What insights can be gained about the interaction between cobalt, selenium, and reduced graphene oxide RGO through the XPS spectrum, and how do these components behave at different depths within the material? How can the information obtained from the XPS spectra be used to assess the material's potential for use in energy storage, catalysis, or other applications? What does the variation in the XPS skin spectrum across different depths tell us about the uniformity or heterogeneity of the material's structure? How can the XPS data be used to track the progression of surface oxidation or other chemical changes in the material over time or under specific conditions? What are molecular spectra, and how are they obtained through spectroscopy techniques? How do molecular spectra reflect the internal motion of molecules, and what types of information can they provide about the behavior and structure of molecules? How are molecular spectra classified based on different wavelengths, and what are the key categories that distinguish these different types of spectra?